Hi folks, I'm going to do a solutions video here for the 3 proofs in the test review. These are 2 of them. The first 2 are the last 2 proofs that I gave on previous unit tests. So if you have a friend or whatever who you maybe have seen the old unit tests from the last 2 semesters, these are them, just to give you an idea of the level of difficulty. So the first one here says, in triangle ABC, where D, E, and F are the midpoints of the sides as shown below, prove that the point P, and P can be anywhere in space, not necessarily in or on the triangle, that PA plus PB plus PC equals PD plus PE plus PF. So we want to prove the left side, which is PA plus PB plus PC, equals the right side, which is PD plus PE plus PF. And this one feels a little bit weird, I think, for a lot of people to kind of imagine that it actually doesn't matter. P could be anywhere in space, not on the triangle, not inside the triangle. It could be anywhere, and this will still work. So one thing, and I've seen a number of people start the solution for this, is that you likely will want to really pick a side that you're going to work with, and we're going to try to connect. I'll probably just start with the left side just because, and replace this PA, so a vector going from P to A, I'm going to replace that with something involving P and D, okay? So I'm going to go, instead of vector PA, and this is going to get totally kind of messy in here, but hopefully it will still be helpful, that PA, I'm going to write that as the sum of vector PD plus DA. So that's what I'm going to do on the left-hand side. So PA is PD plus DA. And just kind of being sure that you are showing exactly what you're doing for each step. You shouldn't skip too many steps or just kind of like jump to some vague conclusion. You have to show me, like, it's obvious that PA, we know going from P to D and D to A, that's the same thing. So I'm going to erase this so it doesn't get too clogged up. But then if I had my point P still out here, then I'm going to pick a different color, and the next one for PB, I'm going to want to kind of connect that PB with a PE. So instead of saying PB, I'm going to say that that's PE plus ED. So kind of finding a different path, because now I'm going to see that I have 2 terms that I want to have in my right hand side. So that and that are terms that I'm going to want to have in my right hand side. And then very similarly for P, oh, I erased my whole P there. For the last one, I want to get a PF. So I'm going to rewrite PC as PC is equal to PF plus FC. So I will go through and do that. So plus PF plus FC. And I'm kind of scooting underneath the right-hand side here. So these 3 underlined terms, those are the ones that I want to keep. That is what's on the right-hand side. So PD plus PE plus PF, that's exactly what I want on the right-hand side. So the rest of this must add up to 0. So I'm going to write this again, plus DA plus EB plus FC. And I have to go through enough steps and show my work clearly enough that I'm showing that this will end up being 0. So this DA Now if I kind of look at these vectors, so I have vector dA here, and then vector EB there, and then vector FC there. So I want to show that those add up to 0. And in order to do that, I need to make a full loop. A vector that adds up to 0 will go in a loop, kind of like here, then there, and then back to the start. So these ones don't do that because they're only half the size of the full triangle. But I know that if I traced around the full triangle, that does make a full loop. So I'm going to list some things that I know because of the fact that these are midpoints. So D, E, and F are midpoints. So I know that BD is equal to DA, and those are both equal to 1/2 BA. So they're half the length of that side. And similarly, FC is equal to AF, which is 1/2 of AC. And then the last one, that one that's drawn in blue, EB is equal to CE, and they're both equal to 1/2 CB. So I'm going to replace these three terms that I really want to get rid of with these, writing those each as 1/2 of a full side. So PD plus PE plus PF is still staying there. And then this will be 1/2 of, which one? DA is 1/2 of BA. And then EB is 1/2 of CB. And FC is 1/2 of AC. So I'm going to factor out that 1/2 and also change the order up just a little bit so that it very clearly all lines up. So I'm taking out the 1/2, and I'm just going to write this as BA plus AC plus CB, just swapping the order of those last two to make it really clear that it's going around in a complete route to end up back at B. So B to A to C, C to back to B. That's going to be the 0 vector. So PD plus PE plus PF plus 1/2 of the 0 vector equals the right-hand side. So that 0 vector will be gone. PF. So left side equals right side there. The next one here, if it says we've got this triangle OAB where OA is equal to 2U and OB is equal to 3V, and it says that AP, this point P, divides this in a ratio of 2 to 3. So that if you divided this side AB up into 5 equal chunks, AP would be 2 of those, and the other one is 3. So it's like 2/5 and 3/5 of the way across that full length. That's what that ratio means. So if we want to prove this, it says prove that OP is parallel to U plus V. If we're asked to prove something is parallel, remember the interchangeable thing for that is that it would be a scalar multiple. So prove that K times U plus V is equal to OP. That's what we want to prove. We need to show that OP is some scalar multiple of U plus V. Okay? Now, there's a lot of different ways to write to write things in terms of OP. So if I was to draw vector OP, there's different paths, and we kind of know both information about both. So it actually isn't going to matter too much which way we do here. I've kind of given the advice to a number of people, look at the paths where you have information, and we actually have pretty equivalent information about both. So I'm going to do this solution starting with OP, starting with the right side of OP, and I'm going to write OP as equal to OA plus AP. But this actually works out just as well if you had followed a different path and gone along OB plus BP. And you just kind of have to do the reverse. So we want information, so we want OP to be in terms of U and V. So we're really going to have to focus heavily on these two side links, like these two vectors here. We want to get totally rid of that AP. Okay, so I'm going to rewrite AP because the P isn't involved at all with the 2U and the 3V. I want just U's and V's in my equation. So I have to get rid of this AP. The first thing I'm going to do is recognize that AP, OA plus, and I'm going to make this 2/5 of AB. Because it's in that ratio, 2 to 3, that is 2/5 of the total vector AB along the outside. Now, AB is something that I can work with. I know that AB, kind of off to the side, I'm going to show this. You could do this in your actual question, but I'm going to say that AB is AO plus OB. Hopefully everybody's okay with that. And AO is negative OA plus OB. So that would be negative 2U plus 3V. So I'm going to replace this AB here with this relationship in terms of U's and V's, going negative 2U plus 3V. And actually, sorry, at the same time, I'm going to replace the original OA with 2U. So 2U plus 2/5, and then I'm replacing the AB in terms of U's and V's, negative 2U plus 3V. And then we just want to see, can we write OP as one scalar multiple of U plus V? So I'm just going to simplify these vectors a little bit. So this would be minus 4 over 5U plus 6 over 5V, and 2U, that would be just really showing my work here with common denominators, though you could really skip this step. That is 6/5 U plus 6/5 V, which I'm running out of space, but 6 over 5 U plus V. So then we could just say, therefore, OP is a scalar multiple of U plus V. Remembering, of course, that parallel to implies scalar multiple. Those really mean the same thing. And the last one. This one doesn't come with a diagram, so we'll have to draw it. Remember, medians are the lines that go from the vertex to the midpoint of the opposite side. So I'm going to draw my triangle ABC, and then AM, so I'll put a point here and call it M, and B to N, and CP, P. And we want to prove that those vectors, so AM plus BN plus CP, are going to equal 0. So I think obviously we're going to have to start on the left side with this. AM plus BN plus CP, and then the right side will just be the 0 vector. Now, one thing that people tend to want to do, trying to get something to equal 0, and I've seen this in a number of cases here, that when people have been trying this, trying to rewrite, say, AM by rightfully saying, okay, I'm going to go A to C and then C to M. And then rewriting another one by saying maybe we'll go here to here, and kind of trying to get one side length going one way and the other way to cancel each other out, trying to think about getting that 0. And I've seen a number of people trying to get, say, like an AB vector and a BA vector and getting those to cancel. And that's not always, like, that makes sense because you want 0, but we've got 3 sides here. So you're not going to get them to balance out like that. I really want to encourage you, if you're trying to get rid of vectors or get them to be 0, that focusing on making a complete route. So kind of going from start, somewhere else, somewhere else, somewhere else, and back to the beginning, that will 0 it out. Oftentimes better than trying to balance it one in one direction, one in the other. Remember that you have that kind of follow a full path. So if we got an AB, a BC, and a CA, those in a row will add up to 0. So that's what I'm going to try to do. So I'm going to kind of follow around in a pathway going in one direction rather than try and go here and get them to balance out, because there's always going to be extra stuff. So that's just to kind of give you an idea of what I would try and do here. So I'm going to hopefully not make too big of a mess with this. But the first one, AM, I'm going to rewrite as AB plus BM. And the next one, B to N, this is where I think a number of people said, oh, I have an AB. If I get a BA, they'll cancel each other out. But then you're still going to have these ones that you're going to need to deal with. So I'm going to encourage you, think about a path that continues a cycle and like matches up to the where you started with. So I'm going to highlight this in a different color. So BN, I'm going to go B to C and C to N. And then the last one, CP, I'm going to go C to A and A to P. I don't know why that didn't do like a highlighter one. There, C to A and A to P. So you see, I'm kind of getting this circular path. Of going around in that cycle. Now, when I know that those big vectors will add up to 0, right? B to C, C to A to B, that's going to add to 0, but I still have those half-size ones, which I actually did see in the other example we did. So we could say that BM is 1/2 BC, and CN is 1/2 AC, and AP is 1/2 AB. So I'm going to replace those in here. So I get AB plus 1/2 BC plus BC, and then CN is 1/2 AC. Oh, sorry, CN is 1/2 CA, not AC. Plus CA, and then AP is 1/2 AB. So now I have 6 pieces, and I'm going to see a bunch of like terms. Like I have AB and then 1/2 AB, and I have half BC and BC, and I also have half CA plus CA. So I'm going to use those like terms and say that that means I have 3/2 AB plus 3/2 BC plus 3/2 CA, and we can factor out that 3/2, and we know that AB plus BC plus CA will equal the 0 vector. So left side equals right side. Hopefully you guys found that helpful. If you have any questions, please make sure to email me.